cloud. All right, so we are recording, and it is time. It's 12:01, so I'm gonna get started here. Are there any questions from last Wednesday? Or before we ask that question, maybe I should ask, do you remember last Wednesday? All right, so that's not my job. Okay. Yes. Yes. Subset versus proper subset. Okay. Yeah, we can do that. All right, so we can work on more examples, and you might have noticed that I'm incorporating the examples into the actual text of the module, which does not mean that you do not need to write any notes, because any thoughts that you have about the examples is not recorded. Okay, so you still need to write notes about your understanding of how the examples work, or how to explain the examples. Okay, so we'll go ahead and start with another example here. Okay, so this time we'll work with a subset of versus proper subset of. Okay. All right, so we'll start with, let's see, how about AB is a subset, okay? So the subset EQ is subset of, and then we want to use another set here, just AB as well. So now the question is, what does this expression evaluate to? Okay, very good. True. The answer is true. It is Boolean because either the left-hand side is a subset of, or it is not a subset of whatever is on the right-hand side. So in this case, the answer is true. Okay, very good. So now I do exactly the same thing, but getting rid of the EQ. So now I'm asking, is the set AB a proper subset of the set AB? The answer is false, okay? Because the left-hand side has everything that the right-hand side has, but the right-hand side does not contain at least one thing that the left-hand side does not have. Okay? Yep. Can you repeat the question, please? Is it commutative? It is definitely not commutative, because commutative means you can change the right-hand side and the left-hand side, and it will still have the same value. So let's look at one more thing, maybe two more. Okay, so I'm just going to do the lazy thing, and this time we have ABC and ABC. Okay, so this time the answer is true for both cases, because AB is a subset of ABC is true, because everything in the set AB can also be found in the set of ABC. Now, the fact that ABC has an extra element C doesn't matter, okay? Because my only focus is, does everything on the left-hand side contained in the set on the right-hand side? The answer is yes in this case. But AB as a set is also a proper subset of the set ABC, because everything in AB is also in ABC, but ABC also has at least one extra element, which in this case is C, that is not found in the set of AB. So is that okay as an illustration? But this, yeah, go ahead. Okay, wait. Okay, you have to make it more specific. You said AB and the ABC is true, but which operator are we looking at? Are we looking at the subset of, or the proper subset of? Subset of, the top one. And okay, so continue with the question, please. Yes. Everything that is on the left-hand side is also found on the right-hand side. Okay, so let's do this, okay? Let's find all the subsets of a particular set, because I think this will help illustrate the concept of subset. So let me go here, and can you give me a second here because I want to see if I can let the other person in because the other person somehow is still waiting, and I don't see any email. Okay, it can be a problem, but I'll deal with that problem later. All right, so I'm going to use okay, list all the subsets of, okay, and we'll use a set, depends on how much typing I want to do, but this is not too bad. I can still do this. Okay, so let me change the other side and probably zoom out a little bit because I think I want to zoom out a little bit so I can have more space. There you go. Maybe one more time. There we go. All right. Can somebody name the first subset, an easy one, of the set ABC? This is a set that is a subset of every set there is to exist. No, ABCD would not be a subset of ABC because ABCD has an extra element D that is not found in ABC. Yes, the empty set. Yep, that is correct. Okay, so the first answer is just the empty set. The empty set is a subset of every set, but it is not a proper subset of every set because the empty set is not a proper subset of itself. Okay, yep, subset. We are looking for, okay, so does it? Okay, let me answer the question and then I'll reformulate the question in a certain way. Yes. Well, the base thing. Mm, well, but when you're comparing two things, there's no one thing of the two being the primary. No, it's just like 3 is less than 4 is not commutative. The less than operator in comparison is the base. I think that's a convention, but there's no such thing as, when we look at operators, there's no such thing as quote unquote which side is the base. So how do we fix that problem? No, read the definition. Okay, so let's go back to the definition and see how these two are defined. Now, there are many ways to define it. The way I defined it in my module is just one of many ways to do it. All right, so let's go back to the notes here, okay? And then we go back to, this is how we define subset of, and this is how we define proper subset of. So the way we define subset of is for everything in the entire universe, okay? Um, oh, X is a subset of Y if and only if for everything in the entire universe, if if something is in X, it is also in Y. So that's the definition. So now you apply this definition to the examples that I have given, and then you can go like, oh, okay, does that make sense? All right, so everything goes back to the definition, which means the definitions are important. If something is important, there are two things that I can think of that you might need to do. One, know it. Two, know how to use it. Okay. In other words, using a more intuitive way to interpret, the word subset of may not be the best way for this class. If there is a more, you know, definite way of defining the operator, then use that definition. All right, so I just got another ding ding of, okay, finally. Okay, so now we have both students in Zoom. Yep. Hmm. No, it would not. Okay, because there's an implication. The implication only goes in one way. So let's focus on just that example. So we'll um okay, I'll do the super lazy thing, which is copying this definition here, copy the clipboard, the tech command, and then switch back to Joplin. Okay, so that we can look at both at the same time. We can look at both the definition and also uh, the example at the same time. So let me see. No, that's not going to do it. Paste. There we go. All right. So let me change a few things here and put a dollar here, put a dollar here. Okay. So that's just the definition so that we can refer to the definition here. So now the question is, okay, the question is, if you have A, B, C, D on one side, and then you have subset EQ, and then you have just A, B, C on the other side, and the question is, what is the answer? Is that correct? Or did you put? I don't remember where you how you phrased it. I thought you said whether A, B, C, D is a subset of A, B, C. Is A, B, C, D a subset of A, B, C? Is that what you asked? Okay, so let me write it here. Is the set A, B, C, D a subset of the set A, B, C? I just want to know whether that was the question. Okay, so in terms, okay, that's good. It is a very good question because I need to make that symbol clear. Because when we see something like this, okay, it is it true or false that X is a subset of Y? That's the question. So is that okay? Yeah, because it's important to associate the symbol with what question do we ask when we phrase it in English? Yes, yeah, that is correct. We are looking for all instances of X when Y is already given to us with three elements of A, B, and C. That is correct. Okay. So are we okay in terms of understanding the symbol? At least be able to translate the mathematical notation to the equivalent sentence in English. Okay, very good. And I just want to go back to my notes here because I just want to see if I phrased it in a very confusing way because I can do that without thinking. Most people think that I intentionally make things difficult to understand. No, it is just my talent. Yep. Uh-huh. You mean in the example side, on the examples? All the examples are now copied into the actual module, so they are here as well. Yes. Okay. So this line here, let me use a mouse pointer so people online knows where I'm pointing. It'd be kind of cool if my finger, can trigger the mouse pointer to actually point to the same direction. That would be kind of cool. Um, hmm? There's smart boards and then there are Wii controllers. Do you guys know what I'm talking about? The Wii controller thing? You can turn the Wii controller into a pointing device where it will follow an IR source. So I can light up a little T candle here, and as long as nobody here complains to the fire department, I'll still be good. And I can put the candle across the screen, and then the mouse cursor can follow the T candle that is lit. I should do that one of these days, just so that you guys can go like, oh, okay, that's just actually doable with a Wii controller and a T candle. I don't even need a pen that emits IR. Okay, anyway, so this says X is a proper subset of Y if and only if X is a subset of Y and there's at least one thing that Y has that X does not have. So, it boils down to, are we understanding the notation of what looks like a subtraction here, which is difference? X minus Y, if Y is a set, X is also a set. Y minus X are the things that are in Y, but not in X. Yes, if the cardinality are not the same. Okay, so which part of the expression are you referencing? There is, but you cannot put it into code by only looking at the length because you have to look at the membership. That is correct. So in this case, X can only be a proper subset of Y if the cardinality of X is less than the cardinality of Y. But that alone is not enough to make X a proper subset of Y. Yes. In other words, the cardinality of X being less than the cardinality of Y is a necessary condition for X to be a proper subset of Y, but it is not a sufficient condition. Yes. Okay, the right side of which expression? I'm sorry, I don't mean to nitpick people, but I really need to know which part we are referencing. Okay, but there are so many operators here. So when you refer to the left versus the right, which operator are we looking at? This operator? Yes, is non-empty. That is correct. That is correct. Yep. So once again, so these are all good questions, because it reminds me to kind of re-emphasize the importance to review the material that is already talked about, and two, more importantly, start with the definitions. Okay, because I have questions about, like in the first exam, not in just this class, in many other classes. It's like, how do I start answering these tricky questions? The first thing you need to do is to know the definitions. Okay, but the exam is going to be open book and open notes to begin with. So that means you need to make sure that all the definitions are easy for you to find in the exam. You start with the definitions. So whatever notation the question is including, you have to know what they mean first. Okay, so you always start with the definitions. Okay, and there are other steps also in order to answer questions, but the first thing that I recommend to start with are the definitions. You have to know the definitions and not sort of know what it means. I really mean, do you know how it is defined? Are we good so far? Okay, and that way of looking at things, generally speaking, is also how I do programming, how I write my programs, how I learn a new programming language. I try not to use the approach of, I sort of know what this is, and I'm just going to play with it until it works. Okay, I try to understand exactly fundamentally what does it mean before I use that feature. I only verify once I think I have a really good understanding of what it is. All right. So are we still doing okay so far? Are there any additional questions? Okay, very good. Because the process of asking questions is important in the process of learning. So let me illustrate or explain the modality, the different modes of learning. One is most people do not want to do reading. Okay, what I have learned from younger people whom I know is people are so used to short content as opposed to long content these days. Once they have to read something that is more than just longer than a typical text message, they go like, my brain is dead. I cannot read this anymore. I cannot maintain that context. Okay. Whereas before people would read newspaper, right? Tiny little font, lots of text, and go like, okay, I'm still following, I'm still following. Okay, so reading is actually very important because most manuals, okay, when you want to learn a new programming language, it is usually in text in some form. Okay, so you have to kind of practice that. Okay, attention span is not something that you're born with. It is something that you can train yourself and extend it. Okay, it's just like muscle. Okay, except it's not visible. So reading. The second one is writing, and that's why I encourage the entire class to take notes, because when you're writing, it's exercising a different portion of your brain. Okay, listening is another one. Okay, you're verbal. Okay, you're listening to me. You're in terms of audio right now, so that's another one. And then when you're asking question, you're exercising yet another one, which is you talking about it. Okay, and all of those are different ways or involve different pathways in your brain, and the more pathways you can engage in the learning process, the more likely you can, one, retain what you learned, and two, apply what you have learned. Okay, so that's why you need to engage as many ways to as many ways to process the same material as possible. Reading, listening, writing, and talking about it, speaking. Are we good so far? Now, don't quote me on any of this because I'm not a psychologist. Yeah, you guys go like, well, we just wasted 10 minutes to talk about something that you're not sure about. But I'm learning, okay? I'm learning how people learn. But aren't you a person too, Tech? I will let you guys decide. All right. So are we good so far in terms of all of these concepts, in terms of what is the concept of a proper subset of, as opposed to what is a subset of? All right. So are we ready to look at all the subsets of ABC? Okay, let's do that. So now I'm going to repost that question over here. Okay. The following is a list of all the subsets of this particular set, ABC. Okay. All right, so we'll start with the obvious one, which is just the empty set. Okay, the empty set is a subset of every set, including itself. And then the next three are pretty obvious too. Okay, so I'm gonna just do a template here. Okay, are we good so far? I know I need to scroll up here on the other side. Okay, do we all agree that the set that only has A is a subset of the set that has A, B, and C in it? Okay, any questions? I saw a hand earlier. Yep. Yep. So those are the subsets that have two elements are next. So we have AB, we have AC, and then we have BC. And if somebody's asking, what about BA? Isn't that also a subset of? The answer is yes, but we have counted it already because the set that has AB and the set that has BA are the same. Because of what? Because of what fundamental property of a set or members within a set? Yes, sets are not, or elements in a set are not ordered. Very good. Yes, I knew what you meant. I just wanted to kind of make it more explicit. Okay, And the last one is just the set itself. So there are 8 of those. Is that okay? Yep. If I were to ask what would be the list of proper subsets, yes, then I would exclude A, B, and C because a set cannot be a proper subset of itself. Yep. All right. So what is the cardinality of the set of all the subsets of a set? Yep. The number of elements of the set is part of it. Yes. There. Nope. It is 2 to the power of n itself. So when we have 3 elements, A, B, and C, there are 8 of these. When we have 4 elements, there'll be 16. It counts the empty set as 1. Yep. Oh, that's also easy. Think of it as 3 digits, okay? There are 3 slots, okay? And one slot is for the presence of A, one slot is for the presence of B, and one slot is for the presence of C. For each slot, you have 2 choices. It's either there or not. Binary, right? But the presence of A is independent to the presence of B, and the presence of B is independent to the presence of C. In other words, you have 3 Boolean variables, and you're looking at all the different ways that you can have combinations of the 3 variables. So when A is present, B can be present, C can also be present. When A is absent, then B can still be present and C can also be present, and so on and so forth. So that's how you make a truth table with 3 independent variables. You have 8 entries in that truth table. So it's 2 to the power of the number of elements. Okay, so you first and then back to you. Yep, go ahead. They're all absent. Yep. Yep, go ahead. Because either an element is there or not. Okay, I can, yes, yes. So this time I'm going to use the whiteboard just because I don't want to set up the tablet. So if you want to copy this, you're going to have to write it down, okay? But since it's going to take me some time to write it on the whiteboard, I think you guys can copy that just fine. So in this case, we have A, which can either be present or not, okay? So we have A being an element of or not being an element of the subset. Well, if A is an element of, then we can look at B, and B also has 2 ways to go. It is either an element of or it is not an element of whatever set we're constructing. And over here, the same thing, okay? B can be an element or it may not be an element of, okay? This is why CISP 430 is a co-requisite of this class, because that class will eventually talk about trees if Iraj has not started to talk about trees yet. But tree is a very important concept in computer science, not only because of the data structure aspect, but also because it is a good way to visualize a lot of things. So C can be present, not present, present, not present, present, not present, present, not present. And now we have a tree. So now you're asking, so what do we get at the end of each branch? What does each leaf represent? What is each leaf representing? Let's just pick a random one. We'll pick this one here. Okay. What is it representing? How do we get here? Yes. Yeah. You track your way back to the root. Okay. You track your way all the way back to the left-hand side. So you go like, okay, if I want to figure out what this is representing, we go like, okay, C is not there. B is there and A is not there either. So this would be representing a set that only has B in it. Does that make sense? That's a graphical visual way to understand, how do you generate all the subsets of a particular set. Okay, you first and then back to you. Yep. No, this has nothing to do with merge sort. Um, it might look similar, but because they're both trees and they're both quote unquote binary trees, which means each node splits into two branches. But otherwise, that's where the similarity ends. Yeah, the trees are representing entirely different things. Yeah, go ahead. In an Mm, well, I mean, if you think about this one, you can recursively do it, right? So the recursive part is you look at each element of a set, okay, and you say, okay, I will put it in and not put it in, and then put it in and then call the recursive algorithm again and say, give me all the subsets, with B and C potentially in it. Because this part here is a subtree. Okay, let me just kind of circle it. This part here is a subtree that corresponds to all the subsets that are possible when you're looking at B and C as elements. And that's why a recursive approach would work easily here, because every subtree is representing the same kind of thing as what the main tree is trying to represent. Yeah, yeah, yep. And then, yep, yep. Go ahead. Okay, we'll pick another random node here, or random leaf. Okay, I did not say it wrong because a leaf is actually technically a node, but I want to focus on the leaf, which means it is at the very tail end of the whole thing. So, and is it related to what he asked? Okay, you might want to write it down because I don't want you guys to lose track of the question that you want to ask. Okay, so let's just pick another, leaf. Okay, so we look at let's say this one here, okay? So the blue one. So now we want to say, okay, what is it representing? Well, when you're at a leaf and you need to find your way back to the root, do you have decision to make? You're starting at a leaf and you want to go all the way back to the root. Is there any point where you go like, I don't know which way to go? You don't have any questions, okay? There's no question because when you go backwards in the tree, meaning from a leaf all the way back to the root, when you go back here, do you have a decision? Nope. C only has this as a parent. So, and then at this point, do you have a decision to make? Nope. You can only go back here. So the blue line is representing, the leaf node that is also colored in blue. So now you go like, okay, how did we get here? A is present. B is absent. C is present. There we go. Yep. I mean, there are many ways to call it, but it is a tree. Tree is a tree. Hmm? It depends on what you want to do with it. If you want to list every single subset of ABC, then depth first search is certainly one way to do it. So then you would be traversing all the way to this one, and then go back, and then go to this one, and then go back, and then go to this one, go to this one, back here, go to this one, and so on. So DFS is one way, but if you want to use breadth first search, it will work too. It's just that depth first search is easier to code compared to depth first search. The other side of uh-huh. You mean in depth first search or breadth first search? In DFS, you should automatically backtrack and know which way to go after that. Yeah, yeah, yeah. I suppose, but the whole idea of depth first search is there's no copying. You're redoing everything once you get back. Yep. Okay, so let me introduce the power set, concept here. It is not in the notes. I will add it back to the notes, but we'll go ahead and explore that because the set of all subsets is known as the power set. So so power set. I just need to find the notation. So the notation of a power set is funky p and then the name of the set. Okay, fine. I can do funky p. All right. So I'm going to introduce a new notation here. Okay, so this is math BBP of a particular set S is called the oops, power set of the set S. It consists of all subsets of the set S. Okay, so that's basically how power set is defined. And one way we know, to calculate the cardinality is this. The cardinality of the power set of some set S equals to 2 raised to the power of the cardinality of S itself. So let me finish that. There you go. And that's a generalization. Now, is that consistent with our observation, with our example? The set that we were working with earlier has 3 elements in it. So the cardinality of S is 3. 2 to the power 3 is 8. Did we observe there are 8 subsets of the set A, B, and C? Yep. Okay. Yep. Uh, you are correct. They cannot be the same. Because even when you are working with the empty set here, the empty set has no elements. So you will be looking at 2 to the power of 0, which is 1. So that means the power set still has 1 element, which is the empty set itself. Okay, so that brings up a whole new topic is can we nest? Can a set contain another set? The answer is yes. There's no reason why you cannot have a set as a member of another set. But then the membership thing versus the subset of thing can get a little bit confusing. Okay. So that's another thing that we can look into, without, I will add all of these back into the notes. But before we go to that concept, okay, let me just kind of write a note here to do, okay, it was just a reminder to myself, okay, add section on nested containment. Okay, that's a note to myself, but we'll deal with that later. But for now, we're going to go back to the module that we were on and also the topic that we were on. All right, so are there any additional questions about the material that we have introduced so far? Yes. I do not know the answer to that. That's a very good question. I believe if you ask ChatGPT, it will give you the right answer. I would not be surprised, because I'm sure Wikipedia already has a page on that one. Because the key is whether it's countable or not. We already know the cardinalities. There will be an infinite number of elements. The question is it countable or not? All right. Any other questions? Yes. When you say bracket, are you referring to this? Braces. Absolute value. The bar means cardinality. Yeah, so it's the cardinality, which is the cardinality of a set is similar to the concept of the number of elements in the set, but it's not exactly the same. Mhm. All right. Any other questions? Yes, please. Okay, because it is the same as the last example. Okay, so let me point to that one. Okay, so the question was, why is this true? Okay, so how would you answer that question? If I were to ask you about that question, where do you start? You mean, so the parentheses is just here to separate the quantifier or the quantification from the expressions that I need to evaluate for everything that I need to evaluate. Okay. Oh, there is something to evaluate. It returns a constant of false. False, yes. But that is still something to evaluate. It simply means P of E is false. I don't even care what E is. The answer is false. Yes. It is a what? Implication? Yes. But to get to the implication part, we have to look at the notational definition. So that's the connection. Okay. The connection is over here. The connection is this notation means exactly that. So now the question is, do you understand that? By definition, um, for every E in X, P of E is something that returns either true or false. It is a quantified expression, or to be more exact, it is a universally quantified expression. But this is nonetheless just a notation. It is a shorthand as a notation to mean exactly that, which is the longhand of the expression. Okay, so the longhand of the expression says, oh, okay, so E being an element of X is actually can be put here, and then it implies P of E. Is that okay? Because this is notation, okay? It really boils down to just mechanical notation that this is the abbreviation of this. It just makes it easier to write. So now, if we know that, okay, and then we go back to the example, and then we ask for every E in the empty set, false. For the entire universally quantified expression, is it true or false? The answer is true because on the next line, it is the expanded version. This is just notation. This is the shorthand of this. Okay, let me do it on the projector here. This is the shorthand of this. P of E is simply false, and X is the empty set. Yes. Yep. Yep. Exactly. Because E as an element of the empty set is guaranteed false because the empty set has nothing. Nothing is a member of the empty set. So this part is guaranteed false. But because this is an implication, if the left-hand side of the implication is false, the implication as an operator returns a value of true. So that means no matter what E you are giving me to evaluate, this entire expression, okay, I have to refrain from using my finger or fingers. This part of the expression is guaranteed true. So that means the universally quantified expression is also true. So that's why both of these have an answer of true because one is just a shorthand of the other one. So now you have to. So there are a few aspects that makes this class or this part of the class seemingly difficult. One is the notation. Okay, it is new to you. You just need to practice and make sure that you study the material. The second part is the concept, the semantics. So there's the syntactic side and then the semantic side. The syntactic side is just mechanical, okay? This symbol means that, this symbol means that, and so on. The semantic side, on the other hand, requires you to understand the meaning of the symbols. So both of those require time, okay, to absorb, to practice, and then to let it sink in your mind. So that would be a good use of the 2 extra hours of time for every hour that we meet here in the classroom. This is not elementary school. I will not require people to turn in a log of how you use those 2 extra hours for every hour they meet here, which basically means for each lecture period, which is 80 minutes, you're supposed to spend 160 minutes to quote unquote study this material. So how do you study this material? That is a question. But if you have a question, well, you can ask me. I'm sure you can find my office hour in the syllabus, and I'm sure you can find the syllabus, and I'm sure you can find the Canvas shell. So I'm backtracking to how you can find my office hour. What if you what if you have a burning question to ask? It is 1 a.m. in the morning and you don't have my cell phone number. And no, I'm not giving away my cell phone number. What do? Ask ChatGPT. And I'm making it easier. Okay, so let me show you one really cool trick here. Okay, I worked on this over the weekend. No, not so much. Yeah, over the weekend. Let me maximize this screen so I can get to the bottom. This part is new. This is a new button, which I'm kind of go like, that's kind of cool because I made it work, right? You guys go like, tag, this is just typical, simple, easy JavaScript on the client side. Yeah, but I'm not used to client side programming, so it's new to me, so it's exciting. So you click this, okay? So let's see what happens when you click that. So you just click, and it gives you a confirmation, as an alert that the whole source document is now copied to the clipboard. And then what you do is you go to your favorite chatbot. Okay, I have a subscription with ChatGPT. You don't even need a subscription to do this, and then you just say, okay, the following is um, mm, teaching material from my professor that presents set related notations. Shift enter so that you don't end the conversation right there. Oh, okay, I forgot one thing. I will be asking additional questions in the following prompts. Okay, so this is something that you might want to just kind of put into like a little notepad, okay, or store it somewhere because I find it super helpful. So I just have a little notepad somewhere else, that I can just copy and paste. Okay, so now shift enter twice, control V. It's like, ooh, everything is here. You just copied the entire source document in Markdown into ChatGPT. Yes. It understands it right away. Yep. Yeah. Yep. So it basically just recognizes everything is in Markdown already. You can always kind of re-emphasize the content is specified in Markdown, but you don't need to do that. So now we can ask questions. Okay. Sam Altman, I think you guys have heard about me saying that, but I'm gonna say it again. Sam Altman said the most useful skill, okay, for modern day computer related jobs is not to know everything. It is not possible. Okay. It is not even um, to think in the case of a problem solving. It is knowing what question to ask. And guess most of your interaction with ChatGPT is going to be asking questions. Okay, so now the question is, I don't know what question you might have in your mind, so I'm emulating what a student might have in this case. Okay, so you can say, I am not understanding the differences between subset of versus proper subset of. Can you give me some examples to help me understand the difference and reference the source material so I can relate the examples to the material given to me? Okay. And my Grammarly is suggesting changes. Oh, that's what all the red ones are about. So if I hover over this one, I'm not understanding. Okay, so it's going to change the other one too. I do not understand. Okay, fine. And this one does not make sense. I don't understand why the period has to be inside the double quotes. From the nesting perspective, the period ends the sentence and the quoted part is a part of the sentence. So this does not make sense to me, but it seems to make sense to most people. Okay, fine. Differences, or there's no comma here. Okay, now it's all grammatically correct. Not that ChatGPT would bother with the grammar anyway. All right, so let's see what is the output. So it's referencing the source material. Okay, those are the same notations from your my notes. Okay, and it should give you some examples later on. Yada yada yada. Okay, so now we got some examples, and it tells you that X is a subset of Y, but not a proper subset of. Okay, and in this case, it's both. AB is a subset of, and also a proper subset of, and the empty set is a subset of, also a proper sub. It's a subset of every set, but in this case, it's also a proper subset of a non-empty set. Oh, look at this! It even gives you a table. Yeah, I may not have a job anymore. All I need to do is to give you like a bunch of prompts at the beginning of the semester, and I'm done. But I hope you guys are learning, about how you can use AI or ChatGPT in this case to help with your studying. Okay, you're not using it to do your homework because I have not given you a single homework yet, and yet you can engage ChatGPT if you need to clarify things, if you need examples, if you need exercises. Okay, give me 20 questions that will ask me or have me to work on a particular operator, and then also give me the answer later on. Okay, so that's one way to use ChatGPT that can be beneficial. Okay, knowing what questions to ask is important because even to ask that question that I prompted earlier, I am understanding that there are things that I'm not truly understanding between subset of versus proper subset of. So I have to formulate the question in that particular way is help me differentiate. That's really an important word. Now, you don't have to use big words, okay? Help me understand the difference between blah, 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 okay? That's fine, okay? But to phrase your question properly is important when you're interacting with a chatbot like this. Now, if it gives you an answer that does not seem to make sense, you can always bring it to my office hour, okay? Or, typically after class I'm free, not today, but after class I'm typically free. So you can say, well, I asked the chatbot about this, it gave me this answer, but it doesn't seem to make sense to me. Can you take a look at the response of the AI and tell me whether it is correct or not? Because the AI can make mistakes. So can I. Okay. So it's always good to re-examine something just to make sure. Yep. Well, there's no implementation so far because we are not writing programs in this class. You can ask for code implementation, but the code implementation of set operations may be restrictive in a certain way, so that they may not reflect the actual mathematical definition of the symbols. I'll give you an example. If you want to contain a set within another set, and then you're asking whether this thing is in the set or not, in JavaScript, it does have a built-in type called a set, but it is only comparing the reference against the reference. So if they're the same object when you created them, then it will say they're the same. But if they are two things, two different objects, even though the membership are the same, they are not considered to be the same thing. Yeah, but by that time you're redefining, the equivalency between the members within a set. So to understand that is even necessary means that you don't need to ask the AI in the first place. Assignment? We don't have any assignment yet. Oh, the element of, right? Yeah. All right. So, okay, I know that was a digression, but I hope that was a digression that may be helpful to you not only in this class, but in all of your at least STEM classes, okay? Because with some other classes, maybe there are a lot of things that are really depending on your point of view, so they can be arguable. But this stuff here is not arguable, okay? It's really just either true or false. All right. Yep. Yeah. Yep. Okay, so for those of you who are curious of how the feature is done, it's easy. Right click and then go to what? Uh, View page source. That's it. Okay, then you can actually see the JavaScript that gets this done. Yep. Hmm. Well, I don't think anything in this class is very arguable. Not only because I'm teaching the class, but also because these mathematical notations and definitions are used in all of your other upper division classes that relate to these notations. Yep. Yeah, it may be something that is a little bit deeper than what we are dealing with here. So what we are dealing with in this class are fairly elemental stuff, and there's not really much to argue about. It's mostly just notations and how we use the notations. All right. So with that said, we're going to move on to the BNF. Okay. I believe that has been discussed already, which is this part here. The general BNF or Bacchus Nor form of a tuple is this. Okay. You start with an open parenthesis, and then inside you have elements, and then you can have multiple elements, and then the elements are separated by a comma. This notation, by the way, was mentioned up here. In other words, I'm just using BNF as described a little bit earlier. All you have to remember is a tuple is a list of things, and the list of things, each thing is separated from the next thing by a comma, and then the entire list is enclosed by parentheses. Is that okay? Kind of like how you specify parameters when you call a C function, parentheses, and then there are multiple items, they are separated by commas. Yes, you mean here? Okay, so the brackets, it was explained up there with the BNF notation. Anything in a bracket that is not in boldface means it is optional. They're meta syntax. They're part of the syntax to describe syntax. No, yeah, you're correct. So this pair, okay, I need to go back to use the pointer. Have to keep reminding myself not to use my finger on the projection screen. So this pair of bracket means everything in between is optional, which means you can have an empty list. And then inside, when you see element here and element here, it is a token, which means it's a token because it is italic and it is a block. Okay, it means it's just a placeholder for something like ABC, tag 23, 64, and so on and so forth. And you can also see the braces. So this pair of braces are not in boldface. So that means it is part of the meta syntax. It means whatever is inside is just a group. Treat whatever is inside the braces as a group, which starts with a comma that is boldface and an element that is not boldface as a token. So whatever you want to do with this group is after, which is this asterisk here. So that asterisk means whatever is right before the asterisk can be repeated in any number of times, including zero. So asterisk means 0 or more of the thing that is right before the asterisk? Yes. Because you need to, if you want to repeat this portion here, everyone has to be separated by a comma. So this entire group has to repeat itself if you have multiple things to specify. The first item is not, it's outside because it is the first item. When you only have one and one item inside the tuple, then you don't need a comma because there's no second item to use a comma to separate from. The first element cannot be repeated because it is not inside the curly brace that has the asterisk right after it. The repetition applies to whatever is immediately before the asterisk, so it'll be just that group. Yep. Well, let's go ahead and make more sense. Okay, so once we understand this notation, which is just a tuple, it is a list. Okay, so now we can define what is the Cartesian product. So the Cartesian product, which is what is in square here, the way it is defined is for everything, for every E and for every F in the entire universe. Okay, the tuple consisting of E as the first thing and F as the second thing is an element of the Cartesian product of X and Y if and only if E being the first thing in the tuple can be found in X and F as the second item in the two tuple can be found in Y. So that's how we define Cartesian product. It is probably best, using an example to illustrate what it means to be, to form a Cartesian product. And before we go, I'm not going to take road today. Okay, so we'll just keep going. Okay, so now we switch back to Joplin to kind of make a few examples. So this time I'm going to make an example of A, B as one set, and then the other side is, eh, do I want to? Yeah, we'll do 1, 2, 3, just so that they have different cardinality. Okay, so this is Cartesian product. I'm looking for a Cartesian product between two sets. The first set on the left-hand side has A, B as elements. The second set on the right-hand side has 1, 2, and 3 as elements in it. So now the question is, what are the elements of this thing? Okay, in other words, what is the result of this? Can someone give me a tuple? Okay, a two tuple. Now, two tuple means it has two things. The word tuple itself, for as far as we are concerned, you can look at it as quote unquote an array or a list. Okay, that's basically what a tuple is. So a two tuple means an array of two elements. Yes. It'll be A1, A2, A3, and then B1, B2, B3. Oops, B comma 3. There we go. And scroll on the other side. There we go. Yep. Yes. And hence the use of the braces. Yep. Is that okay? Now, there's also a graphical way to look at this. Okay, the more graphical way to look at this is to think of it as a table. Okay, you have one thing to designate the column, the other thing to designate the rows, and then the intersection is okay. Pick this from the row, pick this from the column, and then you have whatever is supposed to be in that cell. In fact, the two-dimensional space sometimes is also referenced as the Cartesian space, the Cartesian space between X and Y. Is that okay? The concept of a Cartesian product. Okay. Also, does everybody relate this to the definition? So let me do another trick here, which is also something that I do sometimes in the class. I would take a snapshot of something that I want to reference and then turn it into its own little bitmap that does not go away, and then switch back to the slide that has the actual definition. So this way we can look at an example of the Cartesian product. This is the example, this is the definition. Can we correlate between the two? For everything, for every E and every F in the entire universe. So that would include tech, the car he drives, and so on and so forth. Okay. EF as a two-tuple is an element of the Cartesian product of the set X and the set Y. It is by definition, if and only if, the first thing in E can be found in X, the second thing in the tuple, which is F, can be found in Y. Yes. Yep. Yep. Definitely. You can think of it as a matrix. All right. Any questions so far? Go ahead. Uh-huh. The one above or the one that talks about set containment, because they are basically the same thing. Another thing that you can tag and go like, this is what I might want to read in the extra 2 hours for every hour in the lecture. It's a fairly common notation too. If you read the syntax description of a lot of things, they would use, sometimes they would reference to this kind of notation. It is partly coming from VI or SED or some other regular expression engine, and partially come from the traditional BNF notation. Yep. No, because join is one dimensional. This is two dimensional. Oh, in SQL. Okay, I misheard. Because join can also be used in JavaScript, to join elements to become one long thing. So in that sense, it's not. But in the sense of a SQL table join, it is an outer join because you're pairing with no restrictions whatsoever. But if you don't understand what I'm talking about, that's okay. Just ignore what I said. Yep. So it depends on which part of the ordering. So let me go back here. So if you're talking about within the parentheses, the ordering is important. But if you're talking about between the parenthesized elements, or if you're talking about the elements within the set, then the answer is no, the order does not matter. In other words, in this particular list here, I could have said, A3, B1, A1, B2 in that order. It wouldn't change the meaning of the containment or the membership of the set. But within each member, the element of A1 is not the same as the element, is not the same as the tuple of 1A. Now, 1A is not an element here, but as a tuple, it is not the same as A1. A1 and 1A are two different tuples because ordering does matter within the tuple. Okay. Any other questions before we dive into the whole concept of what happens when a set is inside another set? Okay. Are there any questions on the material that is currently in the module? Mm-hmm. Correct. Yes. So AB is corresponding to the left-hand side of the operator, which is X. 1, 2, 3 is corresponding to the set on the right-hand side of the operator. Yep. Sorry? Nope. The E and the F can bind to anything in the entire universe. So it's asking, is this what determines the membership of the Cartesian product is based on is the first item of the two tuple an element of X, and the second item of the two tuple an element of Y. So E and F are not fixed. They can bind to anything in the entire universe. Okay, you can form a two tuple, with tag as the first item and Iraj as the second item. It is a tuple, not a couple. Okay, so because I don't want to upset Iraj's wife. But but then when you ask, what about that two tuple? Okay, is it a member of, in this case, 1, 2, 3 Cartesian product, AB Cartesian product with 1, 2, 3? Then you ask the question, is tech an element of X, which is AB? Nope. Well, then this conjunction is false already, which means this side also has to be false, which means the tuple of tech, comma, Iraj cannot be an element of the Cartesian product that we just observed. Yes, but we are looking at all the possibilities. We're pairing everything with everything. Everything on the left-hand side is paired with everything on the right-hand side. And every possible pairing is a member of the Cartesian product. Question? Okay, excellent. Yes, the definition of Cartesian product. Yep. They are just choosing some random stuff from the entire universe, okay, as E, and choosing something from the entire universe as F. And I'm just testing, okay, is this expression true or not? But by definition, that expression has to be true. So E and F can bind to anything in the entire universe. E and F do not have to bind to just AB or 1, 2, 3. Okay, so what I meant is this. Okay, so let me go back to Joplin. So what I meant is, in order to evaluate, okay, let me close this now because I don't need it. So if I want to evaluate what we just said a little bit earlier, TAC and Iraj, okay, um, and this is not an element in the set because TAC as E, Iraj as F. When you put it into that equation, put it into that definition, E is not in X, and Iraj is not in Y either. So as a result, this tuple is not in the Cartesian product, given the example that we have. Um, okay, let me finish this and then I'll address that question. Okay, okay, okay. Let me go back and show the definition first, and then we will go ahead. For everything, for every element E, for every value E, and for every value F. Mhm. The tuple that you make out of those two values, E, F, mm, you can, okay, so if you want to read it as every tuple, then you kind of have to put, E, F, into here, as a for all. Basically, you're saying for all two tuple that has two things, then E has to be, the first thing has to be found in X, and F has to be found in Y. But that would be, it's going to be a more confusing notation because we have never talked about using a tuple as a filter of what E can be. Yeah. So this way, I'm not using any additional um, filtering mechanism that we haven't really talked about. All right. Any other questions? And you can ask your ChatGPT to give you some examples. Okay. So let me give that a try. Okay. So this it's the same conversation here. So I can ask you, can you give me a simple example of how Cartesian product works? Okay, there we go. So there you go. Yep. I'm just verifying the answer also at the same time. So it has two examples. Okay, the second example is cute. Okay, it's using the empty set as one. All right, it does a pretty good job with all the examples. And also the conclusion. Even I did not say anything about the conclusion, but it is also correct. So if you look at the Cartesian product of the Cartesian product, if you want to look at the cardinality of the Cartesian product, it is actually just the product of the cardinality of the two sets. So it made that conclusion without me even prompting it. Yep. No, it would not be because an identity means if you use an operator with the identity, you get whatever the other thing is back. So one is the identity of multiplication because anything times one is that anything. That makes it the identity. Right, you get the other operand back. So in terms of Cartesian product being an operator, the empty set is not an identity. It has no identity because because the result is guaranteed to have things that won't match what you started off with because it will be a tuple on the other side, but what you start off with may not be even tuples to begin with. Right, because the requirement is every member inside the Cartesian product first has to be a two tuple, and the most important part is the first item of the two tuple has to come from whatever is on the left-hand side, and then the second item has to come from the right-hand side as sets. But since one of those two is an empty set, there's no way you can actually say, oh, this thing is from that set. As a result, the Cartesian product of two sets, if at least one of them is an empty set, then the Cartesian product is also guaranteed to be empty. Yep. Alrighty, so we are close to the end of this entire module. Okay, and I understand there are a lot of notations and a lot of kind of more or less abstract concepts involved. So it takes time, okay, for these things to sink in. This may not be the same kind of class that you have been taking, for over here. So it does take time to let these concepts sink in. Yep, go ahead. Huh? Nope, I'm not taking attendance today because on one hand, it's taking time. Two, on the other hand, I think when you guys are here already, you probably value your classes a little bit more than some students in CISP 300, which who may or may not know that this is their calling. So I hope that people see taking classes not as much as an obstacle, and and more as a jump board to go to where you need to go. Okay, but that's a choice that is not mine to make. But no, I'm not taking road today, so you guys are good to go. Yay! I'll see all of you on Wednesday, and I do need to run today to the district office, so I may not have a whole lot of time after class. Yes, huh? The last example. You mean here? It is recorded. You can wait until I upload the notes. Yeah, because I do need to run and there's another class, coming in, so I kind of have to go today. Yep. hmm Well, I mean, you're allowed your five, absences to begin with. So, yeah. And, typically if you have a good reason, not to show up, I'm usually okay with, like giving you an excuse, absence if I take role at all on that day. Yep. Yeah. Yeah. Just, send me a note, send me an email, on that day. Yeah. hmm I posted everything on YouTube already. So give me a second. Let me close this one first. Yep, it's the same place that my video is always be. Yep, yep. So if you go here, go to videos, and then it just look up 440, right? So it's right there. Yep. And this is from last Thursday. This is last Tuesday, and this is the first day. Yep. All right. Cool.